Alrighty. Happy Monday, everyone. This is Allison Fortman with Trimble. I'm very excited for this morning's webinar on Ductwork with Fabrication with SysQue presented by Ian. But before we begin, I would like to go over some initial housekeeping items. First, this webinar will be recorded, and after the event, we will be sending this out later on in the week to everyone who has attended. You will be muted through this event. However, you can use the questions in your go-to webinar bar on the right side of your screen. It's at the bottom. Please ask questions, and if we can, we will address all questions at the end if time permits. Have fun and enjoy the learning. Again, for the agenda, this was sent out in your webinar information, but we're going to create a pressure class from scratch, create a duct system from scratch, convert the existing model, and then annotate and create fab files for production. Now, this is a lot of information to get through in the short amount of time that we have, so Ian's going to go as fast as he possibly can. However, we don't want to lose you. So with that, Ian, I am going to pass over to you.
Good morning. Hopefully everybody can hear me. My name is Ian Clement, and about to show you SysQue with Ductwork. As Alison was saying, it is a lot of information I'm going to try and cram into this session, so it is going to be relatively fast and furious. Hopefully, if need be, the recording will actually fill up what we've got. What we're looking at here, I've just got an example model. This is our default as we ship it out, standard SysQue configuration. So a lot of pressure classes and systems pre-built in there. And if we look at the specifications on this, we have all the assorted specifications are behind these. So these are basically what we provide. So bring on this a 2-inch one. These systems are actually provided, also actually are verified by SMACNA. They're all actually based off our, if you can see the little logo down the bottom here. This is the SMACNA standards for the 2-inch. This is how they needed to be defined to create a 2-inch. So we've got this page for the 2-inch. We've got that page for the 2-inch. There's a lot. There's the rod size for the 2-inch, and then went to the 3-inch. So it's a lot of information, a lot of pretty complicated stuff. We've simplified all this within SysQue. So what I've actually done, I've taken this information and just put this into an Excel sheet format, just to actually show you what we're actually interested in. So that's essentially the same information. The only bits that SysQue requires are when either the gauge changes, the connector changes, or the length changes. So that whole table we had can be simplified quite dramatically down to essentially these lines highlighted in yellow there. So basically ductwork up to 10 by 10, 26 gauge, slip and drive. Up to 28 by 18, and this is maintaining a short drive. We've got standing slip and drive. Anything above this size, 42, 42, is 24 gauge, TDC, etc., etc. So basically what I actually want to go through here is actually starting from scratch, inputting the whole thing. Now, this pressure class, the problem you run into with the pressure class is every fabrication shop has their own interpretation of these standards. When to use tie rods, when to change gauges, when to change connectors. It could be relevant on machinery. Do you have a TDC machine, a TDF? Do you only have ductmate, etc., etc., etc.? So pretty much the pressure classes have to be recreated on a per customer basis or per user basis there. So that's basically what you want to run through here. So like I say, at the moment, we've got this. So first thing I'm going to do is, if I get this out of the way, let me, oh, I won't move out of the way. There we go, move that down there. So I'm going to close out of the duct for a second. Within SysQue, the actual duct is all stored within the specifications file. So what I'm actually going to do, delete it. Oop. Delete it. So that essentially is, I got nothing now. So if I jump back into SysQue and power back up duct, SysQue looks for that file, basically says, well, I can't find it. So what it's going to do for me is create me a blank one. And I got nothing. So first thing I'm going to do, again, this is from a speed perspective here. I've got no specifications, so I'm going to start by putting these in. Specifications are broken up into straight duct, rectangular, round and oval, and fittings, rectangular, round and oval. I'm going to start with a straight category here. This gives you maximum flexibility. It gives you all sorts of possibilities of how you can create this duct. So I'm going to call this one, this is for my straights. Just stick an STR at the end of it. And again, from that table, I'm actually entering based off that table. It was all highlighted in yellow. I can go 10 by 10. Finished length, this is slip and drive, 59 inches. Galvanized material, slip and drive connector. And that was 26 gauge and spec. Next entry up there was 28 by 18. 59 inches. This was the standing slip and drive. Oops. Slip and drive on there. Grab that one. And again, 26 gauge. So a little repetitive. What's it is as when we're actually looking at what we're actually doing here, which is this quick and easy to actually input these systems. Now I'm going 56 1/4 for my TDC connections. Obviously that would need to be adjusted based off whatever your TDC allowances are. 56 is actually what it should be, technically, though based on the actual adjustments of your machinery and how your shop actually operates, you may end up with a different number. So 60 by 60, and again 56 1/4, galvanized TDC. Oop, too quick. TDC. This was down to 22 gauge. And we went to 96 by 96, 56 1/4, galvanized, TDC, 20 gauge. And then the final one for this 2-inch pressure class was 120 by 120, which is 56 1/4 still. So it's very, very flexible. You kind of set these up to cover, I always hate to say 100% because there's always some scenario, but that's basically what the humans are for. So that's my 2-inch for rectangular straights. Now, based off the example here, I'm not going to fabricate any of my round in this example. So, but it does need a pressure class in there. So again, this is for straights. So I'm just basically putting in raw for my straight, essentially spiral. And I'm going to just stick it in as 24 gauge. You must have an entry in for, if you intend to use any round stuff, even if you don't intend fabricating, must have an entry in there. I'm not going to use oval for this example. Obviously, you would need to repeat the same thing for oval. Need to do the same thing for the fittings. So again, fitting standards and our specification is separate from the straight standards. So it gives you it's all on a flexibility perspective. So I'm going to use FTG for these. Okay, off that. And on the rectangular again. So pretty much mimicking the same thing. Galvanized, slip and drive. Now I don't need to worry about the finished length on the fittings. SysQue can take care of all that for me. Spec. We went up to 28 by 18. Galvanized, standing slip and drive. 26 gauge. And spec. 42 by 42, galvanized, TDC. That was 24 gauge. Add spec. To 60 by 60, And like I said, these are just those ones I'd highlighted in the Excel sheet. It's always worthwhile when I actually set these things up there, spend a little bit of time looking through what you intend putting in. So rather than actually typing in every single entry, which you could, that works just as well. But based on your typing skills, so mine are slightly limited, I like to do things the easy way. TDC, and we down to 20 gauge. Add spec, and then the final one for this was 120 by 120, galvanized, TDC, 18 gauge. So again, that's the rectangular, and again, you must have an entry in for round, even if you don't intend fabricating that. So like I say, I use 999 as my, I never draw anything obviously bigger than 999 inches on there. Now this, again, I'm working with a spiral system, so I'm just going to go small end, bead and crimp. Same perspective essentially from SysQue's side of things. I'm going to be leaving the oval stuff blank. So now I've actually got a 2-inch for fittings and a 2-inch for straights. Now I do actually want to get a second one in here, so I actually look at some of these duct examples off here. So bear with me while I actually put in a 4-inch one. And so this will basically start to make sense, or why I would actually do this. Oops, that's STR. When we actually get to the next part of this. And again, this is the same thing I'd actually highlighted in the table. I don't think I actually showed you the Excel sheet of this one. Same thing. This is all TDC stuff. So it's all 56 1/4, galvanized, TDC. And that was coming out 26 gauge. And spec. 30 by 30, 56 1/4, galvanized, TDC, 24 gauge, and spec. So really, these entries here are just basically purely where the gauge changes. It's TDC all the way through. Length is the same all the way through. The only entries I need to worry about, or the only break points I need to worry about, are essentially where this gauge is actually changing. It's very rare we see the length changes. Occasionally some shops will actually make their larger duct in shorter pieces to try and save on stiffening. Again, you can do that. That's quite, SysQue will follow you quite nicely with that. The key here is, though, that the specification does need to match what's actually in the fabrication side of things. If this mismatches what you've got in the fabrication, then yes, you're going to have some problems there. SysQue is going to be breaking up duct in one format and allocating one type of connector. But if the shop is expecting to use a different sort of connector or breakout length, then that will generate some issues. So add spec on there. Again, my dummy round one. You do have the ability within the specifications to actually just copy these. It's always arguable, is it easy to actually copy one and modify it, or is it actually easy just to start again? So in this case, I'm actually just starting again. 4-inch WG, FTG. Okay. I guess part of what I'm trying to get across here, it is not difficult to start from scratch. Like I said, this is a completely blank database. There's nothing in this database whatsoever, and hopefully in the time allocated here, we're actually going to end up with a working operational database, though limited. That's back, and then obviously in here you'd also be putting in things like grease duct, welded systems, stainless systems, aluminum systems. I'm putting all this onto galvanized. Again, time's not going to permit to actually build up any additional ones off here, but obviously you've got the same capabilities if need be. That was up to 72 galvanized, TDC, 20 gauge, and spec, and then the final rectangular one was 120. galvanized TDC, and 18 gauge. Add spec, so there's my rectangular done, and finally the round, again just to cover the bases, 999, galvanized material, small end, and 24 gauge, just get me something going there, and spec. So now I've got a 2 and 4 inch fittings, 2 and 4 inch straights. Finished off there, close out of that. And like I said, these are not, again, this is something confusing we actually get. People expect them to show up here. These were specifications, that is construction standards. These are systems we're actually going to use to actually model our duct with. So now I'm going to basically create some systems based around that. The plus, create a system. Now, I'm going to actually name this 2 inch, or base, sorry, 2 inch water gauge. That's my name for this system. Hit the OK. So basically, SysQue is now building that system. And in building, all it's going to be giving me are these straight pieces of duct, rectangular, round, and oval. So once it gets up there, we get this. So all I've got here, a rectangular straight, round straight, oval straight. That's all it gives me. So it's going to start with the rectangular one. Go down to edit this one. Now the duct to duplicate, this is not critical. This is what essentially the routing preferences that Revit will be using, not what SysQue will be using. So I'm just going to pick this radius with taps. To be honest, which one you pick off here is not that critical because this is purely Revit's routing, not what SysQue is going to do. Everything does need a manufacturer. Some of these are actually filled out, some of them aren't. The straights aren't, as it happens. Junction type, I'm going to leave as T, doesn't matter. Service type, I'm leaving blank for now. I'll show you why in a moment. And this is my base 2 inch, so I'm going to allocate 2 inch water gauge. And I would like SysQue to optimize fitting lengths, i.e. increase the length of fittings if it can save me a short joint or eliminate a short joint. So I'm going to leave that one there for now. Okay, off that. Yep. Now on the round, I'm going to do the same thing. So again, this camera is going to duplicate taps and short radiuses. Manufacturer, TRMB. You just have to have something in there. T, junction type, service type, I'm leaving blank. Specification, 2 inch water gauge. Now we're buying these fittings, so I'm going to leave the optimize unchecked. Obviously, you can purchase custom pieces, obviously in round, but if you stick with a factory default, you're normally in a better place. So I'm just going to leave that one set there. Now we're ready to put some fittings in there. Add fittings. So again, there's my rectangular from my Imperial Library sheet metal. Obviously, we have all these manufacturers now in here. I'm going to stick with the generics. So I'm going to start with my rectangular stuff. So, and again, I'm not trying to build everything here. I basically want to transition in there. Drag a transition over. Again, manufacturer, got to be filled out. Now the extended length, this is basically, you can set a default length for the transition. You can also say an extend up to length, which again will, any short joints that adjacent to this transition would get eaten up with. So I'm just going to put 36 in for mine. And again, based on your fabrication shop is what you may need to set there. Radius elbows. Oh, no, that was my default elbow in here. Now the radius elbow, I don't want to ever extend. I don't want splitters in there. I just want it built to my 2 inch standard. And let's get a rectangular elbow in there. Again, this one happens to have a name out. I do want veins, single veins. Now this is going to extend the throats. So I'm going to say, yeah, we can go up to, let's say, 12 inch throats on this. Okay, for that. Want an end cap. TRMB. Specification. You do need the rectangular coupling in there. This is a, it's almost like a fake fitting. This is actually what's used to show the connectors, essentially your TDC, your slip and drive, etc. So it doesn't go anywhere. It's used more for graphical representation. Like I say, we can keep adding and adding and adding. I'm going to, on the duct system, I've actually got drawn here. I've got some various taps on this. So what I'm going to do, I'm going to throw from our multi-shape. Stick on one of these, bell mouth. Again, same sequence. This is going to go for the rectangular stuff. I do want dampers on as a default. I can always turn these off on an individual basis. TRMB. I don't want to extend the length of this. It's going to be a purchased item, but just to build to my 2-inch water gauge. And this is going to be purchased. Make sure you check the little purchase box. Hit the OK. Doesn't really matter whether I put this on the rectangular tab or the round tab. SysQue will normally find it. So let me just get through on some of this round stuff now. And like I said, this is more of a speed thing here. So obviously, this has not got every fitting on there. Less is better. Common mistake we do see people making is they will put every possible fitting that we've got in the library up there. That generally is worse than having too many is normally worse than too few. Again, we're buying it, so I'm going to leave this non-extended and check the purchase box. One elbow on there. Now, I'm actually using our generic, which are basically the manufactured fittings off here for the round. If you are actually buying from a particular manufacturer, drag it out of their particular folder. It's actually a little bit less work to do doing it that way anyway. So I'll get me an end cap on there. TRMB. 2-inch water gauge, purchased. Okay. And I will need a coupling. TRMB. Specification, 2-inch water gauge, purchased. Okay. And this is obviously a very base system on here. Not going to get into too fancy stuff. So it's more from a time perspective, but that is the process of building a complete system. So I've now got this system up here. So if I close out of this is my base 2-inch water gauge. I now need one for 4-inch. So a quick, easy way of doing that, go to use our manager, system manager. I can highlight the 2-inch base, and I'm going to call this base 4-inch WG. And copy that. And so it's basically just copied it, it's identical. So if I close out of here, I've now got the 4-inch one. Well, because I've copied that, if I actually hover over any piece, you can still see it's set to the 2-inch water gauge. So I need to change all these parts back to 4-inch. So again, right click, easy way of doing this. Change the duct, which is essentially the straight duct, to 4-inch. Right click, change all the fittings to 4-inch. Change. Okay, off there. Now, technically, I should also do the same for the round because I'm just purchasing the round. That doesn't really matter that much unless you need to report to the manufacturer whether you're actually getting 2-inch, 4-inch. In general, with round these days is pretty much all fabricated to 10-inch water gauge. So one water gauge standard will work for all around. It doesn't matter if you're actually using on a 2-inch system, a 4-inch, or a 6-inch system. Doesn't really matter. So we've got these two systems up here, but they aren't really what this is. I'm going to end up with some supply medium pressure and supply low pressure on this example. So I now want these named something useful. Again, we use the system manager. So I'm going to highlight my 4-inch one, and I'd like that to be my SA medium pressure. Copy that. Okay, ends up down here. This I want to be my supply low pressure. Copy that. And I probably use my 2-inch, I'd say, for my returner. Just going to call it RA. Copy that. Okay, so obviously once I've got base, it's very simple to actually replicate these out. So I've got these 5 systems now. Close out of this. There's my list. Now, I don't really want to see this base stuff. So I can make use of system visibility. On here, I'm going to just turn off. I could delete, but I just want to turn these things off. Get them out of the way. Apply, OK, and close. So now I've got these. There's my medium pressure one. Now within Revit, what I actually did within the families, I did create some duct systems. Duct systems. So essentially I've got a medium and low pressure system, just color coded, just so I can see what I'm actually doing with these things. So what we can actually do to make this a little bit more automated, on the straight duct only of each system, so on the medium pressure straight duct, if you edit that, this is where I can allocate the service type to it. So I'm going to allocate that as being my medium pressure. This is essentially linking SysQue SAMP, in this case to Revit SAMP. Hit the OK there, successfully allocated. The round could go somewhere different. In this scenario, I'm going to keep it on medium pressure, but actually, in reality, you could have it actually linking to a completely different system if you wanted to, which would basically give you access to different colors, things like that. Repeat that on the low pressure. Edit this. Supply low pressure. Okay, okay. Edit. Now, if you don't fill out the service type, SysQue will leave the existing service type where it was. So if the engineer drew this as just all supply air, typically the engineer will provide a drawing where this is all just supply air. As far as he's concerned, up and downstream, medium, low pressure, not necessarily important. If I leave the service type blank on any of these, then SysQue, whatever this was, it will stay. So again, I think I always find it's worthwhile actually setting these up so you can actually make use of them. So we've got this. Now, again, just making use of some of the SysQue features off here. This is all the duct I've got to work with. Now, it's going to be a bit awkward to know. At this point, I don't know which ones I've done, which ones I haven't done. So I've actually built a couple of templates. And I've built a template, a view template, I've called conversion view. So if I hit that, basically that's faded out all the ductwork itself. It's left the annotation in place, which basically faded out all the ductwork stuff. So I can see as I work through, it's essentially going to fill in what I'm actually done. Now the scale I've got on here, a bit off. So let me just put that back. All you need to do is put the apply the template. So once I put the template applied, I can turn the template off there. I just want to change that back to, looks a bit better on 3/16, just so we can see what we're actually doing there. So this system here, I've got some medium pressure running around here. It's all flat on top, flat on the left. I'm basically hugging a wall coming around here, unhugging the ceiling, running out medium pressure to some various VAVs, ready to start converting. So I've got my medium pressure selected, hover over a piece of medium, hover tab, pick all that stuff up, dot, 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 change system. So this is basically converting the engineers or unbroken out duct is one thing, and these very, very short transitions. These are now being converted to my preferred fittings and defaults. So it works its way through, and we've now got this, and now it's just checking to see what it can actually extend. So what it's actually come up with there, it said, well, hey, I can extend that, fitting in each up a short joint. This transition, it wouldn't help to extend that up to 36 inches. So I've ended up with that coming out there. Now you'll notice, because SysQue is working with the duct fittings family and ducts family, not converting the family type, any annotation that was already up there just stays there. So it saves me having to re-annotate things. I can certainly add additional annotations if I need to, but it saves me having to actually re-annotate things. Now, this is basically all now highlighted, so I can see I've actually done this bit. I'm now basically going to work out on some of the other ones. So let me get back down to a low pressure. So again, I'm going to do, off a tab, pick that one up. Now I can do these one at a time, or I can tab through all of these. Control click, hover tab, tab, control click. So I've basically selected all of the low pressure systems. I've got low pressure up here, dot, 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 change system. So again, that's actually converting those across. That's 22 fittings. And again, it's looking at the parts I gave it to work with and figuring out which bits work best. And you can see it's actually changed the color. I got this just set to orange, just so we can actually see a different color coming out of this. Okay, so now I've got a system that's all changed through. Under that one. Oh, the transitions end up on the tab. Yeah, we'll come back and fix those later. Now, the other thing I actually did with this was actually create a little table, or this was a little sheet view on here. And one thing I actually want to show on there, this is showing me, it's automatically going to fill out with all the purchase fittings. As I change things through, it's actually showing me what I've got there. So there's my round requirements for straight duct, and there is my round purchased list off here. This has a little bit of a weird name, and the reason being that didn't get converted. So let's go see what that one actually is. So again, just to make use of Revit's capabilities off here, if I go down to purchase duct fittings table, which is basically what this table is, I can click on any of these entries, like this one here. I have no idea where that is in the model. Highlight in model, and that takes me to that piece. So that's the one it didn't convert. Reason being, when it's trying to replace the very short radius elbow that the engineer drew with the actual elbow I need to draw, it's too short. It can't fit. It won't fit in there. So this piece is basically unconverted. So if I just drag that out a little bit, give it a bit more. I meant to drag the that one. There we go. So basically, once I got this is the low pressure again. Still got the low pressure selected. I could use change system. In reality, I just needed to reprocess that fitting. So I'll drop it out that way. So you can see the elbow I've got is actually a lot longer than the one the engineer drew. But say very good use of making use of tables and things, so you can actually see what you've actually got there. So if we come back to this, you'll see now that elbow's gone. Therefore, all these are actually purchasable or purchased items coming off that. All right. Annotation. Now, see, it does maintain all the original annotations, so I don't need to worry about that. I probably will do on a piece number it. So I'm basically going to select this, the mains. Now, say I'm going to buy the round. So I could number them around. I don't want to number the round. I'm going to be buying it anyway. Whoever I'm buying it from won't be giving me piece numbers, so I'm not going to worry about that. So basically, come into here, renumber duct, add a tag number. Start from number 1. Again, not being very sophisticated with this. I just want these numbers 1 through whatever. Apply renumber. So essentially, that's numbered up my mains, my medium pressure. Again, do the same thing on here. Grab that one, hover tab, grab that one, and hover tab, grab that one. And again, so just doing the rectangular. It doesn't matter which version, which system you're on here. When you actually do the renumber is like generic. I'm just going to start with number 10, just keep them out of the way. Again, I could put prefixes on here to designate whether it's a supply, low or medium or whatever it needs to be. We've got that one in there. All right. Making the fabrication process. So this will be, a relatively completed thing. Obviously, you might need to add some more bits and pieces on here. That will give me a shop drawing looking something a little bit like that. Now, making the fabrication process easier, I've obviously got a VAV1, VAV2, VAV3, and a mains. So I probably maybe want to fabricate these in little areas. So again, hover tab will pick up this system. What I can actually do from the properties menu here, we've got group number. It just says group number. It doesn't necessarily mean to be a number. I'm just going to call this mains. And obviously it might be first floor mains, second floor mains, air handler 1. It's whatever I want this thing to be. So now from a SysQue world, these all basically have a group that can all be identified separately, which also means in a schedule, I could actually pull out what duct is required for the mains. So I'm going to repeat that on here. This is going to be a group number. This is VAV1. VAV1. Get that one in. Let's do this one. Tab. VAV2. And then the last one, tab VAV3. And again, this is like obviously an optional step, but something I think can make life a little easier on the fabrication side. So basically, I've converted the duct over. I've actually labeled it all out there. We're now ready to actually move on to the fabrication side. I'm going to show the fabrication basically going to Fabshop and to Autodesk Fabrication. Process is very, very similar. In fact, the process is actually identical coming off that. You cannot fabricate from a model unless the model's been saved, which obviously makes perfect sense in the real world. Just going to hit the save on here. Let me call this process. Yeah, process. There we go. So it must be saved before you can actually fabricate from it. So just saving that thing out, and we can now power up Pack, which is basically what's going to take SysQue stuff and convert it into fabrication stuff. Now, the first thing that pops up is our cloud-based projects. This model is called Process. There obviously could be 50 models on the same project. So this is basically allowing me to link them together. This is our list. This is sort of rather garbled list we've got on here. All sorts of things on this. I'm just going to pick something off. It just sort of allocated this project or this model to this project. And this must be done. If you hit close, you've got to do it again. Make sure you hit save. And that will now activate Pack, which brings up this. So let me start off with the Trimble Fabshop output. So I'm just going to put this, I'm just going to give it a name just so I know which one's which. This is going to be output in the Fabshop. So this is the name of the fabrication file I want to create. This is the format I actually want to use. And it's actually US Imperial, not metric. And now because the names I've got for my specifications, for example, could differ from what the Fabshop is, this lets me configure them from here. So this is essentially the SysQue name. That's what I actually typed in. This is actually the Fabshop name I wanted to actually land on. Now, these are completely flexible. You've got the same thing for connectors, basically mapping a name that you may have used in SysQue that you want to use coming out in the actual fabrication file itself. So these are mapped through, make sure they're all actually set. I am going to filter by group number. I'm going to use my group number to select from. So I just want to select all the mains. So this is quite a handy way. If I just want to select manually, I can just uncheck that and choose whatever I want to fabricate. I've got this box checked. It lets me choose by system or by group number, basically off that. By default, it will not allow you to fabricate the same piece of duct twice unless you have this box here checked. If you do, then you can actually make the same piece twice or multiple times. So I'm now going to do select and drag a wind round everything. Doesn't really matter what I drag. It only allowed me to select the mains because that's what I told it wanted. Finish that selection set. And I now get to review what I've got here. So I've got all these straights. I've got these transitions. I've got a radius bend. I've got a cap. This is savable to Excel. So, for example, if you're not in a scenario where you want to actually send an electronic file, maybe actually going to send it out to various fabricators for pricing, etc., I can just export this to Excel. That will basically send out exactly what we're seeing here, broken up by these tabs as an Excel format. This case, though, I do actually want to create the Fabshop file, which is I can use send. Now, this is web-based. To actually create that file, it does take it a minute, and especially when you're actually running on the webinar thing, because it hogs up all the bandwidth. This is basically dumping the file up to the web, and in a short time, with a bit of luck, when it comes back down, yep, we've got the file. So it says, do you want to download it? So I hit the download button. Give it a second to think about that. Actually download the file. Where do you want to save it? So I'm just going to put it in this duct webinar folder on my desktop, just so I know where it goes. Okay, up there, and it just tells me, hey, you've now got a file called Systems Fabshop in that folder. All right. And give it a second, Pack comes back up. Now, what I actually want to do now, I'm going to use CamDuct. And let me just call this CamDuct. And let me do I don't know, VAV1, let's say, off here. And again, you can have as small or as, you know, as much or as little as you want off here. So again, if we do select, just drag a window around everything, and so it's only highlighting what I've told it actually wanted to use. Hit the finish. Shows me a list of that. So in this case, it's got transitions, straights, and caps coming off there. So if I do send off this one, this is creating the file for CamDuct. I say this is web-based, and it is based off your internet connectivity speed of what you get. So it's creating that file, hit the download, stick it in my duct folder, and so again, it tells you it's a CamDuct text file. Okay, it's off that. All right, that's the, let me just close out of this. Let's go take a look at what we got. Close out of that one. And let me start with the Fabshop one, which is, yep, that one there. So within Fabshop, basically, you need to create a job. So I've just called my job webinar. Again, not gone through the process of actually creating the job as part of this demonstration, but basically, you are creating a Fabshop job. You then have the import, and you can then browse to the file. So this is in the Ductwork webinar folder. There's the file, one created a couple of minutes ago. Hit the open. Now, Fabshop basically has a mapping process, mapping whatever's in the file to whatever's in there. I just want to show you that just briefly, not getting too far. So I've created a mapping format called SysQue. Hit the edit on there. This is basically showing me that if it sees the word in the SysQue, we have galvanized with upper and lower case. In Fabshop, it's all uppercase. So it's just showing it what it recognizes each one there. And again, in SysQue, I just call it, it's called a single vein, whereas in Fabshop, I want it actually mapped out as a 2-inch airfoil. That's the name that the shop expects to use. So again, these names can be all set up as need be. It will prompt the user if it runs into something it's never seen before. So I've selected the file, do the import, brings them in there, says there's 9 parts come in. If it did find something it didn't understand, you'd actually get a rejected fitting off that. I'm basically going to save that. There's all my pieces within Fabshop there. So I've got the transition. That's that transition we just entered, TDCs. Was that 4-inch water gauge, I believe? Yeah, 4-inch water gauge. Yeah, all the information's coming across there. It will bring over comments, actually, which I didn't bother filling in on any of those. All the SysQue components have the ability of having comments on there. Didn't actually fill any comments out. Again, more time restrictive. So that's the Fabshop stuff. This is ready now to basically nest, process, print, all completed. Now, obviously, I could modify this if need be. You know, if the shop operator decides he wants to add something, this is completely editable file. The part numbers, back in order, these part numbers do match up. So we got 8 number 1s, 22 gauge galvanized, TDCs, 56 1/4, blah blah blah, all the way through. So let me put that one away. Let's look at the fabrication. Now within fabrication, the names have to be preset. One thing you will find with fabrication is it is going to look for the names you currently have in here. With Fabshop, it will actually, if it finds something that doesn't exist in its database that's come from SysQue, it will prompt the operator to select what is this. So, for example, if TDC has been spelled out as transverse duct connector, when that goes into Fabshop, it's going to prompt the operator and says, I found this thing called transverse duct connector. What is that in our database? With the fabrication, Autodesk fabrication, it won't prompt you. It will just actually ignore the parts. So you do need to make sure that all the connector names, all the pressure class names, the material names, etc., are all preset. If I go into here, sorry, so we're actually in a fabrication blank job, file, import, CAD JCM. Looking for the cam duct file. That's on there. That's generated a couple of minutes ago. Hit the open, runs it through. Now we've got this in fabrication. The mapping side of this, like I said, the name has to exist within here. So these names must be exactly what I typed in, or they were actually mapped for things like connectors, materials, and specifications. The defaults for these fittings, for this end cap, the transitions, the straights, etc., comes from the item folders where you must have the SysQue base items. This is just a folder of all the basic potential fittings that SysQue can generate, and these have actually got the default, well, for example, default names. For example, this comes in called Straight Auto, which is this piece. So this is the one that SysQue's picking up for Straight Auto. So if I need my name to change, I can just rename this thing. And the next time it comes in, it'll have a brand new name coming off there. All right, that was about that was 45 minutes, I guess, because Alison did take a couple of minutes. That was basically running start through finish, creating a complete database from absolutely zero, dropping it into Fabshop and to Autodesk Fabrication. So I'll pass it back to Alison.
All righty, thank you, Ian. That was amazing. We did get a couple of questions, and so I'd like to try and address those if we can. The first one is the renumbered duct tool numbers, duct randomly out of order. Is there a way to get it so that the selected ducts are numbered in order?
It basically goes through the straights first, then it comes back on the fittings. You do have the option in Renumber. I guess you have to select something first. Yeah, we'll select it. You do have the option of the manual selection for moving things around. I know exactly where this is coming from because it does it on occasions where it will give you a rather strange number in just a strange place. It's been improved quite dramatically, so it's not done too bad a job on this. There's all my number ones, then we're into number 2, then there's all my number 3s and number 4, 5 and a 6. These are 2 different length joints, a 7, 8. Now we're back to 6s. That's a full joint. These are all the same joints coming off there. It does do a lot better job than if you've got a much older version, yes, you'd end up with some rather weird things going on the numbering. You've always got the option of using the manual select over there. You've also, and again, if it's a one-off, not something we'd want you to have to do all the time there. Every piece has an item number. So for whatever reason, I could name this as 1A, let's say manually. Obviously, I don't want to be doing that for many of them. But if there's one that just isn't right, I can change it there. But essentially, it does start at where you start from and numbers in that sequence, and it's much better than it used to be. I'll leave it at that.
All righty. The second one, I'm going to start with the example this gentleman had given and then ask the question, which is, if I wanted to offset 6 inches in a different direction, it'll default to placing generic 45s where I would ideally want it to just place the radius offset or transition fitting. Is there a way to have it default to place radius offsets while drawing as opposed to the default of placing 2 elbows for elevation changes?
Right. That comes back to essentially a function of Revit. Revit itself has no offsets, so it's going to basically generate the 2 elbows. SysQue lives on top of Revit, obviously, and SysQue actually basically follows whatever Revit gives it. So if Revit's actually drawn it out as 2 45s, then SysQue's going to come back and says, oh, you want 2 45s? That's what we're actually going to do there. We have addressed it on transitions. Now, hopefully at some point, maybe we can do this with SysQue. We have addressed it with transitions. Now, I don't know whether this is something that anybody's actually seen or whether whoever it is that actually questions actually seen that. If I've got a piece of duct there, that's 8 by 12 at 7 foot 9.5. And just zoom in a bit. And let's draw another piece of duct that's going to be 14 by something completely different, 8. And let's put that at 8 foot 6. And that's over here somewhere. Let's say, as an example. Now, I just want to show this may not actually, this doesn't really address the thing. You always have the ability of selecting both of these, right click on the transition and place fittings. So that's basically generated a transition between the two parts coming off that. It doesn't, when we have the ability to do that with radius offsets and even mitered or square offsets, then I think that will actually completely solve the problem. So the actual key to the problem is the fact that Revit does them as short elbows, or 45s typically, and so SysQue's following on that. So.
All righty. We're getting a flood of questions now.
Oh, good.
Oh, I'm just kind of looking through. One gentleman was curious what the installation drawing looked like.
Oh, I think you mean that. Was this what you meant by the installation drawing? I mean, I regard that as like a shop drawing.
Yeah.
Yeah, obviously you probably need a few extra bits and pieces there. Now, again, I didn't put any hangers on here. If I'd applied the hangers and then you're actually using, like a Trimble robot, let's say, to lay all these out, the idea would be that I don't need to actually know how far off the wall this is. If the hangers are in the right place and I put the duct in the hangers, then we're good to go. Obviously, I can just use, generic Revit to, I guess if I need to activate the view, to use generic Revit to go from there to either the center of the wall or the edge of the wall. So, go. That's a bit of a little number off there. So I can add additional annotations in here if need be. But that, well, that will be my idea of essentially a shop drawing and an install drawing. And like I said, to add the hangers on here, which obviously we haven't really got time to cover within this session, within an hour. Then yeah, we'd be good off that.
Okay. Is there a way to keep the exact fitting length during processing for routing in tight areas?
I believe what you're talking about there is maintaining the fitting length per what the engineer drew. The answer to that one's actually no, not from what the engineer drew. Now, once it's been SysQued, or a SysQue fitting, I can maintain, for example, that length all the way through. But pre-processing, I'm going to say no. I can't think of a way to do that. Because the first thing that SysQue's doing is changing it from essentially generic to it's following the rules as per set on this. So essentially, all the fittings within SysQue, these are just families. So the cool thing is you can just double click on the thing and you can get all the parameters. You could, yeah, don't know. I actually set that as, I don't think you can keep that as a default, not what the engineer drew. Okay. Once you get to SysQue, you're good. But pre-SysQue, no. I don't think you can.
The gentleman came back with the last question where it was, what does the installation drawing look like? And yes, can you show how all install annotations are added for a field shop drawing?
What
Do we
additional
have time?
annotation? Sorry, yeah, what additional annotation? I guess that would be the question.
We may not have time for that one, but we can definitely follow up with that.
Yeah, I just say I'm not quite sure what the additional
Okay.
Obviously, I've got the ability to add additional sizes if I need to on there. I could add. I don't like the idea of putting duct lengths on this or offsets. The question becomes why. But yeah, we can address that, I think, as a separate. Yeah.
Okay.
Separately.
So I think we only have time for a couple more. So the first question was, is there a way to adjust the radii of a radius elbow? And then secondly, can you demonstrate the transition process again?
Okay. Radius elbow. And again, this comes back down to a default. You can set a default. If I double click on any fitting, go to its properties over here, I can set the default down here. So we have as like easy ones as like 2 times center radius, 1.5 or 1 times. If I always just want that coming off there, there's nothing to stop me making my own formulas. If I want 1 3/4 inch or 1 3/4 times radius, I could do that, or just a fixed value. It's just Revit. I could do that. Now, anything I've already got in the model, like the one I just clicked on. So this one here, if I want to change the default on there, come to its properties, and again, see, I've got these switches, or I can update just the actual radius itself. If I want that to be 1.5 times center radius, done. So anything can be changed that way. And then going back on that transition-y thing again. So basically, I guess just delete it. Probably the easiest way, isn't it? Rather than struggling to draw that. So basically, I've got here two different size bits of duct, 2 different elevations coming off there. Select both, right-click on the transition. Now, I say currently it does only work for the transition. Hopefully, we can get this added to additional fittings there, but then place fitting. And that basically goes through and generates the actual transition that's needed. So that there is whatever that one ends up being. So dimensions, length, and again, it is following the rules that were set on the transition of, I think it's up to 36 inch if you can save a joint. Obviously, there's not enough space there for it to save the joint. So basically, select everything, right click on the transition off the menu, place fitting. Okay.
Okay, well, thank you, Ian, and thank you all for being a part of this webinar this morning. I know it took some time out of your day, but I hope you all learned something. We will have this webinar recorded and that's sent out to you either by the end of this week or early next week. And we will follow up with you all individually on those who had questions that we couldn't get to. All righty, thank you and have a wonderful rest of your week. Bye, Ian. Thank you.
Bye.